Hello everyone. Today we're talking about kinematics for IGCSE at Maths. In kinematics is all about using calculus to describe motion. You'll be working with equations that links displacement, velocity, and acceleration all together. In here, you learn about how to differentiate displacement to give you velocity and differentiating velocity to give you acceleration, or the other way around, where you have to integrate acceleration to get velocity and integrate velocity to get displacement. Okay, this topic isn't just about memorizing formulas, it's about understanding how motions work mathematically. We'll break down each concept step by step and show you how to approach these exam questions. So let's start off with your first question over here. A particle travels in a straight line, its displacement s meters from the origin at time t seconds, where t is greater than 2, is given by the displacement formula of s equals to ln 4t squared minus 5 minus t, right? So find the expression for the velocity and acceleration a of the particle given displacement. To find velocity, first we have to differentiate this. Differentiating the ln equation, you would have to differentiate whatever is inside here to get 8t over, copy down the whole function, 4t squared minus 5, and differentiate the minus t to give you 1. Okay, this will be your velocity formula. Now, to get your acceleration formula, what you're going to do is you're going to differentiate this one more time. The acceleration will therefore be differentiate top, you have 8, copy bottom, you have 4t squared minus 5, minus differentiating bottom, you have 8t, and then copy back the top, you have 8t again. This value over the bottom square, 4t squared minus 5 squared, right? And then differentiate 1, you get nothing. So this will be your acceleration formula. From here, all you have to do is just expand and simplify it. You get 32t squared minus 40 minus 64t squared over 4t squared minus 5 square, and finally you should have gotten negative 32t square minus 40 over 4t square minus 5 square. Okay, now in the next part of the question, find the time when the particle is at rest. Now in this kinematics, you would actually see this kind of phrases very often. What I want you guys to remember is when the particle is at rest, this simply means that the velocity is 0, meaning to say it's not moving, right? Okay, so when v is equals to 0, find the time. Substituting v equals to 0, 0 equals to 8t over 4t squared minus 5 minus 1. Therefore, to solve for t, what we're going to do is just bring the 1 over, okay, is 8t over 4t squared minus 5. Bring the 4t squared over, you have 4t squared minus 5 is equals to 8t. And finally, solve it like a quadratic equation. 4t squared minus 8t minus 5 equals to 0. Factorize this whole thing here. You would have 2t, 2t, and you have 1 and 5 here. This will be positive, this will be negative, equals to 0. Therefore, t can either equals to negative half or t can equals to 5 over 2, of which we're going to be using the value of t equals to 5 over 2, and we're going to ignore this value here, simply because time cannot be a negative value, right? Okay, so therefore t is equals to 5 over 2. Now, the next part is find the acceleration at this time. The acceleration when t equals to 5 over 2, all we have to do is just substitute it into the equation here. Okay, substituting it into the equation, you would have negative 32 5 over 2 square minus 40 over 5 over 2 square minus 5, the whole thing square. Type this into your calculator, you would have gotten top part is negative 240, bottom part is 400, and therefore the acceleration will finally equals to negative 3 over 5. Now, what does this negative 3 over 5 actually mean? For a negative acceleration, this is actually deceleration. Okay? Yep. Next question here. In the next question, a particle is traveling in a straight line. Its displacement s meters from the origin at time t seconds is given by, again, a displacement formula here. Find the expression for velocity and acceleration of the particle. So to find the velocity of a displacement formula, once again, we're going to differentiate and differentiate, right? So differentiating this, the velocity is actually equals to 2 times 1.5, you get 3e to the power of 2t. Then negative 2 times 2 minus 4e to the power of negative 2t. Differentiating this, you get minus 1. This will be your velocity formula. Then next, for your acceleration formula, we're going to differentiate this one more time to give us 6e to the power of 2t. Then negative 2 times negative 4 plus 8e to the power of negative 2t. Differentiating minus 1, you get nothing. So this will be your acceleration formula here. Now, find the time t seconds when the particles is at rest. So once again, like I mentioned, when particle is at rest, this is when v equals to 0. 3e to the power of 2t minus 4, I'm going to change this into over e to the power of 2t minus 1 equals to 0. By now, you should be familiar with this part already. This is actually a quadratic equation. Let y equals to e to the power of 2t. Then you have 3y minus 4 over y minus 1 equals to 0. Multiply y on both sides of the equation, right? You would have gotten rearranged 3y squared minus y minus 4 to equals to 0. Quadratic equation, right? Then factorize this, you would have 3y and y makes y squared. Negative 4 and 1 gives positive 1, gives you negative 4 here. Therefore, y is equals to 4 over 3, or y is equals to negative 1. Now, remember that we are not solving for y. Y is simply e to the power of 2t is equals to 4 over 3. And then what we're going to do is we're going to ln both sides of the equation. Ln this side, you're only left with 2t is equals to ln 4 over 3. And therefore, t is equals to 2 bring over is half ln 4 over 3. Okay? And if you wanted to convert this into decimals, 5 times ln 4 over 3, this would have equals to 0.144. But I won't use rounded up values here. I'm going to use the exact value because I'm going to use it for the next part of the equation, next part of the question. Next part is find the acceleration of the particle at time t seconds. Okay. Oh, one more thing I forgot to mention. We're ignoring this value because if you can't ln a negative 1, yeah. So this one is ignored as well. Ignored. Right? Okay, back to this part. Find the acceleration of the particle at time t seconds. The t seconds is referring to the answer that we just got here. So to find the acceleration, all we have to do is 6e to the power of 2, this whole thing here, half ln 4 over 3, right? Plus 8e to the power of negative 2, half ln 4 over 3. Right? Typing this into the calculator, this would just end up giving you 4 over 3 because e and the ln will eventually cancel. 2.5 will cancel as well. So you get 4 over 3 here. 6 times 4 over 3 plus 8e to the power of negative 2 again times here and then times here. You get negative 4 over 3 like so. Okay. Then finally typing this into your calculator, the acceleration is therefore equals to this times this is okay, this is 8, sorry. Then plus this will give you 6. So your final answer is 14. Okay. Okay, next part. A particle moves in a straight line at time t seconds after passing through a fixed point O. Its velocity v is given by v equals to 10 sine 2t minus 6 cos 2t. Now, in this question, we are given the velocity formula. Find an expression for acceleration. We're still differentiating this. Differentiating 10 sine 2t, you are going to get differentiate sine gives you cos, right? So 2 times 10 cos 2t, and differentiating cos will give you negative sine minus 6 times negative 2 sine 2t, right? Finally, you would have gotten 20 cos 2t plus 12 sine 2t. Okay, and the next part is a very straightforward question. Oh, by the way, this is the acceleration formula. Find the acceleration when t equals to pi over 4. All you have to do is substitute pi over 4 into your equation here. 20 cos 2 bracket pi over 4 plus 12 sine 2 bracket pi over 4. Type this into the calculator, you would have gotten 12. Okay, 1 mark question. Now, next part over here, find the first time at which the acceleration is equals to 0. So we're going to let this equation equals to 0, right? 20 cos 2t plus half sine 2t is equals to 0. Then bring the sine over. 20 cos 2t is equals to negative 12 sine 2t. Then what we're going to do is we're going to bring the cos and the sine to the right hand side and the numbers to the left hand side. You would have gotten 20 over negative 12 is equals to sine 2t over cos 2t. You're supposed to get tangent 2t. Okay? And from here, what we're going to do is we're going to find the referencing angle, invert tangent of this is 5 over 3, right? Type this into a calculator, you would have gotten a referencing angle of 1.03037, so on and so forth. Now, since we're looking for the first time at which acceleration is 0, and if we plot out our A, S, T, C, we know that this is a negative value, right? So it's going to be here. Then my 2t value would have been typed into the calculator 2.11, okay, which is basically pi minus this value here. Okay, this is how I got 2.11. And lastly, since this is equal to 2t, t would have to be this divided by 2, 1.06, rounded off to 3 significant figures. Okay. Last part here, find the displacement of the particle between t pi over 4 and t pi over 2. So, since we're looking for displacement and we are given velocity, then what we have to do is we have to integrate the velocity formula here. Integrating it, you would have gotten that displacement is equals to integrating sine, you would have gotten negative 5. Okay, let's write it like this instead. 10 cos 2t times with 1 over negative 1 over 2. Okay, minus the integrate cos, you have gotten sine, but it's 6 sine 2t. again times 1 over 2, right? And then from here, we are going to put the definite integrals of negative 5 cos 2t minus 3 sine 2t between the limits of pi over 2 and pi over 4, right? Type this into the calculator, you would have gotten 5 minus negative 3, which ultimately gives me 8. Okay, so this will be the displacement here, 8 units.